The U.S. defense industry is very focused on critical technologies, disruptive technologies, which includes hypersonics. Hypersonics is anything that travels at Mach 5 and faster. It's important because when you look at the geopolitical environment, there are threats and potential threats that we need to be prepared for, and hypersonics will provide our U.S. military the cutting-edge defense that we need to protect our country, protect our warfighters, and keep us all safe.
Hypersonic flight is fundamentally different simply because it's faster. The same way that F1 racing is fundamentally different than a high school cross-country team, that's how hypersonic flight is different than conventional aerospace. Things are happening 10 times faster, 10 times hotter, maybe 100 times hotter.
The OEMs and the government officials who are in charge of acquiring and procuring these weapon systems know to come to ATI for the best material to make these successful.
The materials that are used in a hypersonic platform, whether that is an offensive missile or a defensive missile system or even a reusable system, requires high performance materials that can withstand the aerothermal heating requirements while also maintaining strength. So that would include materials like high performance nickels, niobium-based alloys like RC103, and then titanium even for structural portions of those systems.
As the government thinks about scaling up some of these hypersonic programs, what's the easiest way to scale and what's the most cost-effective way to scale? And we think really in many cases, metals provide a unique opportunity to really hit meeting those speed, meeting that temperature requirement, while also providing a cost-effective solution. Whether that's an additive manufacturing flow path or a sheet or plate manufacturing flow path, a lot of production opportunities, a lot of cost savings.
I think without ATI, hypersonic development would be at risk of being able to source the kinds of materials that they need for flight. ATI serves that field in a number of ways by being a provider of record on a lot of programs. So we have the reliability that we provide and knowing where your material comes from, a domestic secure supply chain, and then being able to be responsive to unique and extreme material requirements is really how we do it.
Refractory alloys, specifically niobium, are critical for hypersonics because of their ability to maintain strength at high temperatures. So ATI has taken a strong interest in developing more hypersonic alloys. Specifically, we are working to develop the next generation of materials that go beyond the traditional like C103. We are looking at alloys that have been used in the past and moved on from because they could not meet the needs at the time. But as technology advances, some of those alloys are coming back into play. We're looking forward to developing them as sheet and powder, as well as tube and bar to meet the needs of our customers. We're also looking into new and different alloys that have never been melted or produced before at scale, and we hope to be able to do so in the near future at purities that have not been seen before to meet our customers' strong demands.
So the refractory metals are metals, which means that they have a lot of capability in terms of our ability to make them to a lot of complex forms and very large forms as well. But what really enables metallic materials to meet these challenges is that you can make them at a very large scale, weld them together, and make complicated shapes. This is very difficult in other material systems, and really only the refractory metals, and niobium in particular, which is very fabricable, can you have both high temperature properties and the ability to make large complex structures out of it at the same time, as well as do things like repair and expect it to have a lot of tolerance to damage.
One of the really interesting things happened during their space race, not so much Apollo as the shuttle era. There was a huge material development effort that ATI participated in heavily when we were designing the shuttle. There had been metallic systems designed for the shuttle, which was reusable reentry, which looks a lot like hypersonic vehicles because you're using it multiple times and it was kind of a plane-like object. And so a lot of the things that we learned, a lot of the legacy information and alloys and processing that we did in that era, we are kind of bringing that back to address the modern hypersonic era.
When you think about any vehicle design, it is of the utmost importance to make sure you're in the early design phases, right? Once that design is locked in, it could be 4 or 5 years till that vehicle is actually produced. Those material selections are happening now. So for us to be partnering with our customers, partnering with the OEMs, partnering with the people doing the research and the design is critical right now, and helping them understand what's out there currently, what could be out there from an ATI development perspective is very important to help them make the best decision so that they can create the best solution for their customer and to make sure our material is on that platform. And our ability to be on those designs in that 2030s is dictated by what we're doing today, tomorrow, and in the next couple months.